Alright, so in section 6.5, we're now talking about using these factoring skills to solve equations. So you're going to have equal signs now, alright, and you're going to use the zero property. So for instance, like number 3 there, you've got x minus 3 times 5x minus 3 equals 0. So when you do that one, just remember, this works off the special property that if you have a times b is equal to 0, what does that tell you about a or b? Well, it tells you that either a equals 0 or b equals 0 or both a equals b equals 0. So at least one of them has to be 0, which means we just solve them separately for 0 and then we solve. So that means we have x minus 3 has to equal 0 or 5x minus 3 equals 0. It's called the zero property. So you're going to get x equals 3, or you're going to get 5x equals 3, which gets you get x equals 3/5. So your two values of x that make this equation equal to 0 is there. Okay? Zero property. So I try to circle those for you so you have them. That's the key property that you need. Now moving down here, one that looks a little bit different. If you have a problem that looks like this, x times x plus 4 equals 0. We use the same thing, but except this one looks a little different and confuses some students, and you include that. That does matter, okay? So again, we have the zero property, a times b is equal to 0. In this case, this is a, and this is b. So that means just plain x has to equal 0, okay? Or x plus 4 equals 0, so just don't forget the x part, okay? So that one's already solved, x equals 0 or x equals negative 4. So x equals 0, x equals negative 4 are the two values of x that solve that equation. Okay, that balance the left side with the right side. Alright, now, a question like this, x squared minus x equals 0. So sometimes you have to always try to take out a GCF first, okay? If possible. It doesn't always work, but see if you can. You can see here that you can divide x evenly into both. And then you're left with x times x minus 1, which brings you back to a case like this. Alright, so we know what to do once we have that. We just set, again, since a times b equals 0, we set them both equal to 0. So you have either x equals 0 or x equals 1. Same idea. Moving on down. Okay? So let's say you have something like yeah, okay. So if you have something like x squared plus 2x minus 24, we're used to doing a problem like this without the equal 0. So we just factor it like we did in the last section, and then continue on the right-hand side. When we're done, set them both equal to 0. So we know how to do this problem. This is going to be two numbers that multiply to negative 24 that adds to 2. So that's going to be positive 6 and negative 4. So that's what goes in here. Doesn't matter which side you would put which. You get x squared minus 4x plus 6x, which is plus 2x, and then minus 24. So now, the only difference between the problems we're doing in the previous section and now is that we have an equation, which means it's set equal to something. In this case, 0. 0 is your friend. That makes things very easy. It makes it considerably easier. So x minus 4 is equal to 0. So x equals negative 6 and x equals 4. And those are the two numbers that if you put them back in here one at a time, will make 0. So just to show you, if we put a 4 in here, we're going to get 16 plus 8 minus 24. And you see that does equal 0. Let's put a negative 6 in. You get 36 minus 12 minus 24, and you see that does equal 0. That's called checking your answer. I'm sorry, I was off camera there for a minute, but I put in negative 6 and 4 into this equation one at a time, and it showed that the left side and the right side both equal 0, just to prove that that is the solution to the equation. So a solution to an equation balances the left-hand side with the right-hand side if you have a correct value. That's what that's for. Alright, sometimes if you have something like this, you have to bring the value over, you have to bring this over and set it equal to 0. So right now it's not equal to 0, so you can't do any factoring. See, these already equaled 0. So what you have to do here is you have to add 3x to both sides. And then you get x squared plus 3x equals 0. I'm not going to finish that one. I want you to do that on your own, but then you try to take out a GCF and get x times x plus 3. And then you solve it just like you did the other ones over here. Okay? So the new step there was, what you have to write down for your notes there is set equal to 0, take out GCF if possible, then factor. So we don't try to factor right away, and then set each piece equal to 0. So those are our key steps right there, which you want to keep in mind, okay? Those are the key steps. Let's keep going. So let's try that one. Okay, fine. All right. So if you had something like x squared minus 7x equals 60, well, the first thing you have to do there, again, you have to set equal to 0, right? That's what the first step is there. Set equal to 0. Is it equal to 0? No. So it's like a little checklist for you, okay? So that means we have to subtract 60. So if x squared minus 7x minus 60 equals 0. Now we try to take out a GCF. There is no GCF to take out, because it has to be able to take out of everything. You can't do that. Next thing, try to factor. So we try to factor, okay? So try to find two numbers that multiply to negative 60 that add to negative 7. So it has to be a positive and a negative, and they have to be 7 away from each other. And so it looks like 12 and 5. So it looks like positive 5 and negative 12. So I'm going to go positive 5 and negative 12. And that equals 0 because we subtracted 60 from both sides. So we're going to x equals negative 5 and x equals positive 12. Okay? Just so you see that step right there, I'm kind of doing it in my head, I guess. So if x plus 5 equals 0, you're subtracting 5, and that's how you get x equals negative 5. And over here, you're saying x minus 12 equals 0, so you're adding 12 and adding 12, and that's how you're getting x equals positive 12. All right? Just make sure you see that. Moving on. Okay. So try one of these guys. Sometimes the number before the x is not a 0. So we have to do trial and error, not a 1, so we have to do trial and error. If we have 3x squared minus 5x equals 2, okay? Now that one there, we have to set equal to 0, right? So you subtract 2 and subtract 2, and you're going to get 3x squared minus 5x minus 2 equals 0. Now it's not so obvious because, again, this is a case of the number in front of the x is not 1. That's the ax squared. I called that a before in the last class. So therefore, we have to have two parentheses. It's got to be 3x and x. Now this is trial and error, okay? So you're looking for numbers that multiply to negative 2, all right? So it's got to be a positive, it's got to be a negative. It's going to be 2 and a 1. Probably like maybe a negative 2 and a positive 1, since I have that negative term there. So let's try that. I don't know where to put what, but let's try that. So if I put a negative 2 here and a positive 1 here, that'd be 3x squared minus 6x plus 1x. Oh, that's minus 5x. And then minus 2, so that works. So that equals 0, so you set each piece equal to 0. And you get 3x plus 1 equals 0. And you get x minus 2 equals 0. And you get x equals 2. And you get 3x is equal to negative 1. So x equals negative 1/3. And x equals 2. So those are our two answers to that kind of question right there. Just so you can see. Let's take a look at what else we have here. For the function, find f of 1. All right. So when they say something like use f of something, we'll show what it looks like. So if we have f of x is equal to x squared plus 2x minus 13 is equal to 13, find f of x is equal to 2. All right. So that means that they want to know what number do you put in for x, the domain value, makes this whole thing equal to 2. So they're giving you the same kind of problem you did before, but they're kind of giving you a backwards way of saying that if I put x in here, this is going to equal to 2. So what number? We're trying to find we're basically trying to solve the equation. So how do we solve the equation so that it doesn't equal 0, it equals 2. So what value of x gives that 2? So basically, we just start with the problem like this. And then we just have to subtract 2 and subtract 2 to set equal to 0, because remember we always set equal to 0. And then we solve the problem like we did the previous ones. All right, now it looks like a problem that we know how to solve, because we can factor this. And we can see that two numbers that multiply to negative 15 that add to 2, that's going to be 5 and negative 3, right? So x plus 5, x minus 3. So you can see that minus 3x plus 5x is plus 2x minus 15. So x plus 5 equals 0 and x minus 3 equals 0. So you're going to get x equals negative 5 and x equals positive 3. So this problem is really doable. It's just this little symbol here is throwing you off. It's basically saying, what number do I put in so that the whole answer equals 2? So that means that this stuff equals 2. That's the mental leap to make there when you read the problem, so you understand that. All right. Let's do one of these word problems. All right. So take the rectangular carport. So you take the carport question, or product two consecutive integers. So when they talk about two consecutive integers, basically two consecutive odd integers. So if you say the product of two consecutive odd integers, so that basically means you have x, and if the next one that's odd, it's going to be x plus 2, right? Because you need two numbers to get to the next consecutive odd number. So that means x times x plus 2 is going to equal whatever number, 783. So you just multiply that number, multiply that out, set equal to 0, and solve. So that's the only new part there is you have to write it this way. Consecutive means in a row, but it's odd numbers, okay? And then the last one there I'll do with you. So rectangular carport has 2 square feet. That's really small. Rectangular carport has an area 2 square feet. The height of the carport is 3 feet less than 2 times its length. Okay. So all right. Find the height and the length. All right. So the height and the length, and the whole thing that multiplies to 2. That's what they're saying. So the height of the carport is 3 feet less than 2 times its length. So here's length L. And so this height right here, we're going to write down it's 3 less, not 3 minus, but minus 3, than 2 times its length. So it's going to be 2L. That's the key part right there. You have the length, and then the height is equal to 3 less, minus 3, of 2 times the length. So when you do area is equal to, in this case, length times height, okay? Length times width, really. Length times width equals area equals 2. So you multiply this guy, so you can have L times 2L minus 3 equals 0. So then that's the key part, and then you just solve L equals 0 or 2L minus 3 equals 0, and then you solve for L in both cases. You know how to do that part. I don't need to do that for you. Just want to break that down and show you how you represent this with 2L minus 3. So length is what's being compared to. So the height is a function of the length. That means that you write the height with an L also, so you have the same variable. Okay, same thing here. An integer and the next consecutive odd integer. If they said the next consecutive integer, it would have been x and x plus 1. But they said next consecutive odd integer, so it would have been x and x plus 2. All right, because they said x was a consecutive integer to start with, yes. All right, so that's enough for there, and that should help you guys get through 6-5.